All right, ladies and gentlemen, boys and girls, gather back around the radio or the iPod, wherever you guys are in the world. Man, I am so excited to have you. You guys are in the right place because we are joined by the co-founder of DoubleZero, Austin Federa. We're not joined by Brendan, my co-host today. As you guys know and love him, he's out of the office, so you guys are stuck with me. But Austin and I are going to have an awesome conversation. And yeah, Austin, I couldn't be more excited to have you. How are you doing today?
Good. Thanks for having me back on.
Yeah, no. Last time we spoke, you were repping the Solana Foundation. You were the former head of strategy over there, and been there for years. I think we talked to you a couple times, and you were kind of the go-to guy when we were learning about where was that whole ecosystem going, how was it going to be growing, and you were spot on because you were really pounding the pavement early on, and but you've since left. And you've started your own thing, as they say. You've started your own thing. So I want to know about DoubleZero. You're the co-founder of it. People, have probably heard your past and your history in some of the other episodes. So let's kind of just, jump in to DoubleZero and what kind of what it's about and what made you start it.
Yeah, certainly. So DoubleZero is set out to sort of solve what I think we'd call like a fundamental problem facing blockchain today, but it's not a problem most people are aware of. So at its core, what we're doing at DoubleZero is building a new internet, but that doesn't mean exactly what you think it means. So most people, when you say, oh, we're building a new internet, they're like, oh, you're going to like rebuild Facebook and Google. And it's like, no. We're talking about the physical cables that the internet runs on.
Oh.
So today, the public internet, which we all know and love and is an incredible product and resource, runs primarily on fiber cables that run around the world. There's hundreds of these that run underwater across continents and across oceans. There's tens of thousands of terrestrial fiber cables, probably hundreds of thousands all over the world as well. And this is what carries the internet today. But this system is built on 40 years of basically cobbled together different types of systems. And this is why if you look at the traditional financial space, they don't really use the public internet that much at all. If you look at like a high frequency trading shop, they're pretty much never touching the public internet. Everything they do, from market data to trade data to executions to all this type of stuff, runs over private dedicated lines. If you ever read Flash Boys, this is exactly what that transformation was about saying, look, if you can be smart or you can be fast, you should pick fast, because sometimes you're wrong if you're smart, but you're never wrong if you're fast. And this is basically like the whole theory that's like all these HFT firms have been operating on for years at this point. At the same time, most large public companies and like large technology companies have started to invest pretty heavily in fiber and physical infrastructure. So this started with, Facebook goes from a dorm room company to a large publicly traded company. But even in that sort of run up into profitability in the early days pre-IPO and even after IPO, they weren't really running their own physical infrastructure. But at some point, Facebook decides, look, our biggest barrier to growth is two things. One, we need more data center space. And two, the internet's pretty slow, especially in our growth markets and new markets that we're trying to go into. And so even a company like Facebook says, we're going to start building our own data centers and we're going to start running our own fiber. They wired up the Philippines. Most of the fiber cables in the Philippines are run or financed by Facebook. And that was entirely so they could sell ads to people. Like every large Web 2 company or even Web 1 company eventually reaches the size where it starts thinking seriously about the physical infrastructure that its software business operates on. And crypto never really had that moment, right? Crypto's gone from, 15, 16 years ago, Bitcoin launching and sort of starting to slowly change the world, to fast networks like Solana, to Mega ETH, to Monad, to Sui, to Aptos, to all this new stuff coming. It's all still running over the public internet, and it's still competing with all of the other web traffic that you see today. And the goal of the DoubleZero project is basically to accelerate the entire space by about a decade by throwing more connectivity at it than anyone has previously thought possible, and doing so with a whole bunch of new technologies that are simply not available on the public internet today.
Wow. What are those technologies that are not available to the average Joe?
Yeah, so there's little things that sound like little things. Like multicast is a really great example of this. So multicast, most people encounter multicast actually in their home, but they don't really realize it. So if you are using AirPlay speakers or Chromecast speakers or Sonos or something like that, where you're sending music from one location, your phone, to multiple speakers, you're using a technology called multicast. And what that does is it basically allows your phone to send, or your laptop to send out one packet. And then the network automatically replicates those packets and sends them to all the places they have to go. It is basically hardware accelerated packet distribution. And this, seems like, oh, this is a great idea. Like why isn't everything run on this? Well,
I thought it was all Bluetooth.
yeah, right. No. It's all running over your local area network in your house. This is why, if you remember back in like the old days when you bought a Sonos system, you had to buy this like weird router from them too, the Sonos Link Bridge or whatever it was called. This was because like home grade routers at the time didn't support multicast, but now pretty much everything does today. And this is really efficient because if your phone had to pull in 7 copies of the song, first off, that's suddenly 7 times as much bandwidth, and then it has to send all those 7 copies out to each of these speakers. Well, that's also a huge amount of replicated bandwidth, and your phone would just kind of overheat and, it would suck up the battery much more quickly. So you might ask, like, why don't we do this in the public internet? Everyone wants to stream the Super Bowl at the same time, and if you're based in the United States, the experience of streaming the Super Bowl is not very good, right? It took probably 10 years for companies to figure out how we actually stream big sports events.
Oh, wow.
Because multicast doesn't exist on the public internet. You can't simply broadcast out something like the Super Bowl feed and say, well, anyone who wants to tap into it can tap into it. This is part of what made radio and original broadcast television, even satellite television, and even cable television so easy. Is you're just sending out one copy of the signal and anyone who wants to can tune into it. Because the
I had
internet
no
was,
idea it didn't even work like that.
yeah, exactly. So like if you're tuning into like FM radio, like back in the old days, right? There's just a big antenna sending out a signal and you're just tuning into that signal the same way you can, tune your radio and you can pick up signals from satellites or air traffic control or whatever, any sort of broadcast that's unencrypted. It's not an opt-in service. Like they don't have to say, yes, you can listen to it. You just tune your dial to it. If I want to receive packets from YouTube, my computer has to go request them and then YouTube has to send them to me. And so if there's 1 million people in the world trying to watch the same video, there's 1 million copies of that video flying over the public internet at any given moment.
And so you're changing that.
Yeah. And so long story short, what's really cool about multicast is it allows the server to send the packet once and the network gets it where it needs to go. And this is not how things exist today, right? Today, if you're a Solana validator or a Sui validator or an Ethereum validator, you are sending out copies of your block that you've built to every single other node in the network. And there's trees and multiplication. So on Solana, you send it to 200. On Ethereum, you send it to a bunch of your neighbors. They send it to a bunch of other people. But it's this very inefficient system. It's very censorship resistant, which is really nice, right? Especially in the early days. Like it's out BitTorrent. BitTorrent is an incredibly censorship resistant protocol, but it's very slow. And so to actually get the state, all the changes that have occurred from the block I've built and the execution data associated with that to the rest of the network actually takes a lot of time. Only about 2% of an Ethereum block is actually executing in the block. The rest of it is just basically waiting for the data to move around all the validators in the world. Even on Solana, where block times are only 400 milliseconds, validators spend a huge amount of time and a huge amount of bandwidth sending copies of their data out to everywhere else in the world. And it works pretty well on Solana, right? There's 1,400 validators and another 1,000 RPC servers on Solana. It's the network with the highest number of validators for how fast it is. But if we really look forward into the future and say, well, blockchains need to be doing 1 million transactions per second, that type of packet multiplication math that's necessary if every validator has to send all of their packets all the time to all these locations gets us into places where the amount of bandwidth required is basically untenable. And the amount of time it takes to distribute all these packets and everything is like meaningfully slowing down these networks. And so One of the other things that DoubleZero does is it brings really dependable connections to all these validators. So running over the public internet today, like it can feel like everything's super fast, super responsive, but we all get Zoom dropouts every day, pretty much. We're like, oh, we're on Zoom, and like, oh, wait, what'd you say? Like, drop some packets there, right? Video degrades, maybe it drops for like 2 seconds.
It's happening to us now on this this podcast recording.
There you go. Yeah, and like it's fine on my end, but it's not fine. You know, something in between the data I'm sending to you is getting dropped, whereas the data you're sending to me is totally fine because these pipes are not symmetric, right?
Yeah.
What's going upload and download are not the same activities. There might be more geographic traffic heading from my direction to where you are, and so my packets are going to get, dropped or scrambled or something along those lines. If we're on a video call, that's fine. But also, like, this is why we're using Riverside to record. The whole point of Riverside is it stores a local copy of the video and makes sure every single one of those bits of data is uploaded to the cloud correctly. So when you go and you edit the video after the fact and you upload it to all of your subscribers, they're getting this like nice, pristine video quality. They don't have to deal with like shitty Zoom quality video. Right?
Yeah.
Just to plug your show for a second. But that same problem applies to high performance systems too. Except if I don't get a bit of data, it's not like, oh, well, like I heard 95% of your sentence. I can probably guess what you were saying. The thing we all do every day where we're like, I'm pretty sure I know what this guy was talking about.
Yeah.
You can't do that on a blockchain. You can't do that on a high performance system. You have to instead say, wait, sorry, the connection dropped. Can you tell me what that thing was again?
Yeah,
and
you
then
can't be like, I think he meant I wanted to buy 1 Solana, not 10 Solana. Or I think, it's like you had to have factual 1.1523 is exactly what he wanted. And that needs to be certain.
Exactly. Humans are very good at filling in the gaps. We don't want computers to fill in the gaps for blockchain. Yeah. We want to be 100% sure. Totally. And so that means like just as you have to do with a person, you have to go, what was that? Oh yeah, I meant this. Okay, great. Yep, I've recorded it down. Now we can keep going. That takes time. Mm-hmm. And all of that back and forth time is now time the network is not producing blocks, it is not advancing forward, or it's not able to reach consensus. And so the whole point of DoubleZero is if we can build this new physical fiber network. And this is like cables in the ground, physical fiber, like everything is physically interconnected to itself. If we can get this built out and have it run by enough independent contributors that it has properties we all know and love in blockchain, like censorship resistance, cryptographic security, economic security, we're going to be in a position where we can accelerate what's possible in blockchain by probably a decade. Like when we get so we're in testnet now, but like when mainnet hits and we have, like hundreds of gigabits per second of data, we have multicast running, all these types of things, we can handle dozens of Solanas, dozens of networks that are targeting 1 million transactions per second. And the goal here is not to say like, okay, great, then, we can push, maybe Solana decides to push itself to 10 million transactions per second. That would be awesome. But really it's about saying, like the transition from 2G to 3G internet is like what made the mobile phone revolution possible. I think people forget how much of a flop the iPhone was until it got 3G. Mm-hmm.
You couldn't do anything with it until the App Store and those downloads, and you could take them on the go, and like that's where the magic happened, right?
Yeah, like I remember using like my mom's iPhone or something when I was like a kid, and it would be like, oh, we're waiting like 30 seconds to load the weather. This was not like, but then suddenly you get to the 3G iPhone and dating changes forever. Taxis change forever. The entire mobile revolution kicks off because the base layer connectivity between these devices, which were fundamentally awesome, but they weren't great if they were on Wi-Fi. That connectivity layer got fast enough that it could bring about social revolution and social change. And I really think that like we're at a tipping point with blockchain where we have all of the components, but we don't have any of them running fast enough or cheap enough really today.
Hey, look, I could absolutely get behind it. I think it's awesome. And I definitely think, we need it. I remember reading this one book and it reminds me of you. And maybe this could be your new nickname, but it was about a guy named John Malone who, it was called The Cable Cowboy. And he was the guy who was responsible. Yeah, great book. He was responsible for laying all this cable all around the world that, all these, things like AT&T could, leverage and so on. And so what you're saying is that, all of this, call it traditional infrastructure, it's just not really equipped for, a world of decentralized, billions of transactions a second. So we need to upgrade it. The IP, whatever version of IP we're on, it kind of maybe doesn't support it. Is there anything that like the system can do without like that DoubleZero, like, that could maybe obviate DoubleZero in a sense? It's like if we just updated IPv7, would it then be able to support all these things that you're trying to do? And are you really trying to push like the world to get upgraded here? Or is it just like we actually need something completely else?
Yeah, so this is a great question, because I think a lot of people assume, and I kind of assumed at the beginning, that some of this was just a technology problem. Oh, people haven't invented this stuff. The stuff doesn't exist yet, or something along those lines.
Right.
It is as much a technology problem as a business case problem. So the way that like your ISP makes money on your end is they bill you every month for an internet connection. Great. Okay, cool. But what happens from there? We all know that like just because like Verizon provides me internet service, I can reach stuff that the Verizon network isn't on. This is in fact the point of the internet, is that I'm not just stuck to like the Verizon stuff. I can go, if you're running a server in a data center connected into AT&T, my computer can still talk to it, and we can, download an episode or something along those lines. This is the whole point of the internet, the interconnected networks, right? So how does that work? Well, there's this whole billing system where basically it costs your ISP money when you access stuff that's not on their system. And it costs the other system money when they access stuff that's on your system, right? And so there's this really complicated billing arrangement between all these different ISPs, which effectively gets them into a system where they're incentivized not to give you the best quality of service, but to get rid of your data as quickly as possible. If they know it's not heading somewhere they can service, they would much rather push your data off onto someone else's network and make them have to try and figure out how to get you there. So if you actually like go and download like, a traceroute system or something like that and run it from CLI, and you try and ping like a server in Japan, and you watch every hop and every trace route that happens between you and there, your packet is probably bouncing around the eastern seaboard for a while before it actually starts heading across the United States.
It's like hot potato.
Completely, because everyone's just like, I don't want this packet. I don't want this packet, because they're trying to get it to Tokyo, and there's not actually a ton of bandwidth that goes between the US and Tokyo. And so the question is like, well, who's going to take it? Who's going to take it across the ocean? The crazy one is you can be in Argentina and talking to a server in Chile, 500 miles apart, and your packets will clear through Miami.
Wow.
The data will go all the way up and all the way back down.
It's physical traffic, right? At the end of the day, like we don't think that it's like physical because we think it's just light or just electricity, but there's like physical constraints. And this is actually bringing back to memory like net neutrality. Like there was this whole debate of like, should all internet traffic be treated equal? I don't know how it all kind of turned out. I think
they
that
nuked it. It's totally gone in the United States.
Which is probably the right way to go. It's like you could kind of it's not all created equal. There's people that are willing to pay a lot more to get their packet from Japan to America than just a guy who's trying to stream cat videos. It's like there should be a marketplace for that. So that's an interesting one.
Here's the craziest piece. There is no marketplace for that.
Okay, so maybe that's what you're solving?
You would think that would exist, right? Like you would think that like it's 2025. If I am Fortnite, I should be able to go somewhere and say, look, put our Fortnite traffic ahead of everyone else's traffic. We're going to give you a bunch of money, but I really want
not exist.
I really want the teens to be able to buy their skins. In order for them to buy the skins, they got to get the headshots. So it doesn't exist. There's no universally accepted packet prioritization schema for the internet where a company can just go and buy prioritization. If they did, Zoom would pay it. Zoom bills us whatever, $12 a month for like video conferencing for some reason. We all pay for it. Like if they could make it so our packets and we'd never get a drop in a Zoom call, they would do it. But here's the thing. This is like a classic problem that blockchain is really good at solving. There may be 40 companies between my house and your house, right? Like 40 different networks this thing is transiting through. How do you keep track of that accounting? How do you keep track of who gets paid? Right?
That's crazy.
These systems were never built for this type of thing. And so today, if you want to make sure your traffic always gets Like if people in the United States can access your server in Tokyo and you want to make sure that they can always have a great experience, you know what you do? You set up another server in the United States. This is called a CDN network, a content delivery network. This is Cloudflare. This is, a whole bunch of companies that do that type of thing. Netflix does not have like one big data center. They have data centers in every country and most major cities in the United States to serve traffic locally because they can't depend on the public internet to actually deliver a high quality streaming experience, especially when new shows are coming out. So what they'll do is they'll put like an entire copy of the entire Netflix library in New Jersey. And so if I'm streaming it in New York, I'm going over the effectively, like, we don't think of like a city as a local area network, but it kind of is a local network. The connectivity between my house and New Jersey, like all of like 12 miles away, is way better than the connectivity between my house and say Philadelphia or my house and Boston, right? Even though like the distances aren't that much greater, just the way that these networks have been built out. And so you have to sort of think about this and say, okay, well, like if every big company in the world is using a CDN network, if every financial technology company in the world that's doing high frequency trading also is effectively doing this, they have their own fiber cables run to the exchanges, they're trying to front run everyone and land their packets as quickly as possible. Like, why is blockchain stuck on the internet? Right. And that was like the fundamental question. And, my co-founder, Matteo Ward, actually tried to, he sort of like started pitching this and tried to build it in 2017. But blockchains weren't fast back then. Ethereum was the fastest blockchain around and it did 14 to 20 things per second. Like it just wasn't necessary. But we get to a point now where we have all these fast L1s, all these fast L2s. And it really, you can see that the thing holding back these networks are the networks, right? Like, ironically, it is the internet as the fundamental fabric is the thing holding back all these fast blockchains today.
Wow. No, it's crazy that this is stuff that, most people don't really even think about. Like, we think, oh, we get a Netflix show, but we don't think about how it's actually physically getting to us. We open a web page. And then you send a crypto transaction. You don't think about that stuff behind it. So yeah, the first, it's awesome that we were able to spend such a good chunk of time kind of unpacking that concept. And yeah, you did a really great job of kind of breaking that down for a 101 level. And so, and I think this next question is kind of a good segue here, which is the name DoubleZero. I feel like that's a very descriptive, telling name that will actually even continue to kind of inform this entry level discussion here that we're understanding of, like, how are these blockchains and people actually talking to each other? So where's the name DoubleZero come from?
So it started off as kind of like a code name just because we needed to call it something. And like all code names, unfortunately, they stick. So DoubleZero refers to this idea of basically two concentric circles, an inner ring and an outer ring. And one of the things that DoubleZero does is we actually employ a bunch of hardware accelerated filtration on the ingress and egress of the network. And so if you're two validators, right, on the DoubleZero network talking to one another, let's say they're Solana validators, they're sending all their traffic over this internal network. And that's sort of like safe, protected, secure space because everything on the network is already kind of verified, right? We also have filtration on internal traffic too. So like the two rings is more of like a logical construction than a physical construction. But then you can imagine stuff coming in from the outside, right? An RPC server located outside the DoubleZero network, a validator located outside the DoubleZero network. Suddenly there's a real possibility that the traffic that thing is sending is full of spam. And so we use hardware acceleration on FPGAs to do things like signature verification and transaction deduplication and throwing away of things like DDoS attacks and that type of thing before it actually hits the network. Because right now what happens when a validator is building a block, they receive all the full force of the internet, sending them traffic, trying to block out, their block building capacity, all these types of things. And so by having DoubleZero filtration sort of intermediating that inbound traffic, what we hand off to validators are transactions that pass signature verification, stuff that's not duplicate transactions. We block a bunch of stuff from getting to them that otherwise would have. And so it can make the whole network faster because there's less sort of junk to sort through before it actually builds a block.
I love that. No, that makes perfect sense. And I like the name. And I like when names start as just inside jokes that kind of stick. But so walk me through this idea. So I remember again going back to this, idea of laying, physical cable and building physical infrastructure. I mean, this is such a hard nut to crack because it's so capital intensive. I mean,
Yes.
where are we going to get the billions of dollars to build this, and so on and so forth. And I remember there's a company called Helium, and they had the same idea, and they were like, or not the same idea as you, but they had this idea of like, we want to, replace the Verizons and the AT&Ts of the world. So we're not going to build out the infrastructure. We're going to, pay people to host hotspots or something like that. And so that was kind of how they tackled this idea of like, capital expenditure. And so if are you going to take the money that you raised to build out physical cable, or are you going to try and incentivize people to contribute their cable, or how does that all work?
Yeah, so we raised 28 million, which is certainly not enough to be building like new undersea cables. And so what we are basically working on here so these cables actually exist, right? There's a lot of them out there. They're just pretty inaccessible to like normal folks. And also the economic incentives don't really support, like, apart from like the Ethereum Foundation or the Solana Foundation, like unless a foundation were going to take on this on their own, like the economics just become very hard for an individual entity to do. So what DoubleZero does is it's an open source protocol that allows contribution of bandwidth resources to the network. And so our earliest contributors include, basically folks who already run private fiber networks themselves. So like, Jump Trading is an example. We have, a bunch of other like Distributed Global is an example, TerraSwitch, Latitude, folks who already either run data centers or run fiber networks themselves are basically carving off, 100 gigabits, 10 gigabits of their global networks and saying, we're going to dedicate this to DoubleZero.
So it's like DoubleZero is like a decentralized virtual toll road, basically, network for all of your traffic.
Exactly. Yes.
It's badass, man.
It's pretty cool. One of the craziest processes going through this is I'm obviously not the network engineer, but we have an incredible founding team of engineers, and Andrew McConnell is our CTO and co-founder, and the pace they've been building this thing is just like incredible. Like we gotta test that up and running at this point, but it's been really interesting to see just how quickly this thing can go. And the whole idea of this with multiple independent contributors is if we built this as one centralized company, it would be a major censorship point in blockchain. And so instead, by building this with multiple independent contributors, the idea is that the network is much more resilient. It has the type of multi-party security that people usually expect from any project in blockchain. And the other thing too is folks can always fall back to the public internet if DoubleZero goes down or is compromised at some point in the future. Now they may go from doing 1 million transactions per second back to 10,000 transactions per second, but falling back to safe mode is much better than falling offline, right? And so we think that we can work with all these networks and allow them to take advantage of the additional resources that DoubleZero can throw at them, while also building in the sort of security of like, well, if we have a bug or something along those lines, they can fall back to using public internet for these types of things too.
Totally. No, it's awesome. And just to help us think about how it would work. So, you're not going to be interfacing with the everyday person who's making transactions, but you're really underneath the hood. And so does an Ethereum app developer kind of need to engage with DoubleZero, or does the Ethereum Foundation actually need to get this kind of worked into the EIPs and worked into kind of the overall code base? And does, Aptos and Sui, and like, is this kind of an initiative that you're taking on in order to get DoubleZero integrated across all these networks? Like, how does that happen?
Yeah, so there's a bunch of different ways this can happen. So one of them is just quite simply that like the validator community says like, yeah, our goal is to go faster than the public internet allows. Like we are on board with this. We're going to try and adopt this technology. This is basically what happened in Solana. Like the core protocol devs are like, yeah, we want to build out a bunch of support for DoubleZero, and assuming the community likes it, like we'll adopt this thing and use it. There's other networks like L2s, for example, that even though they run centralized sequencers, they can still really benefit from the added features of security and these sorts of things that like DoubleZero provides. And so with the L2s, like they're centralized companies. They're easy to talk to. They all have contact forms on the website. You can just like send them a telegram. You can get on a call. Like it's quite easy. It's a lot harder on something like Solana or Ethereum, like to basically just reach consensus around this is something worth doing. So we spend a bunch of time with the Solana community, basically seeing if this idea was palatable to them, because it was entirely possible that it could not be, right? If you are running like an L2 or you're building a new L1, the foundation tends to be the right entity to do the engagement with, but some of the protocol teams also, like the folks building the core clients, can be really great entry points as well. This requires minor protocol changes. Like you have to teach your client how to understand multicast and these sorts of things. But it's on the order of weeks of work. It's not months of work to sort of bring a lot of these optimizations to it. And then kind of rolling up one level from there, like we also have RPCs and MEV systems as like primary users of the network as well. So from a user perspective, they may never know, oh, my transaction's going through DoubleZero, but they may be subscribed to an RPC provider that is operating on DoubleZero, or is even selling them like, hey, do you want to send your transaction via DoubleZero? It's going to be faster and the deliverability is going to be better. I'm going to charge you more money for something like that, right? You can see all of these, the same way that like stake-weighted connections are more highly billed on Solana than non-stake-weighted connections. So we're trying to basically be as like stay out of the prescription for how a lot of this stuff will work, but instead give developers the tools that they need to basically figure out like, okay, where would DoubleZero fit in our stack? And that's going to be a different answer from Solana than it will be for Aptos, or than it would be for Avalanche, or it would be for, an L2 running on the Optimism stack or something like that.
Yeah, no, I completely agree, and I think that's the right way to do it. Just gives people the ultimate flexibility, and at the end of the day, it seems like it's pretty general purpose that it could kind of interface with many different networks.
Yeah, we actually built it not just for blockchain. That's the other thing too.
That makes sense too.
Yeah, you could see CDN networks getting built on top of this thing, indexing services, ZK proving networks, AI training, and inference centers, like all sorts of different types of systems. What we're really trying to do is, and this is like a more macro level blockchain story, but it applies outside of blockchain too, is we are seeing like a very rapid winner take all market in the technology space. Like people are like, oh, the NVIDIA GPUs are great. It's like, yeah. We've got all that type of thing going on too. But like what we also really have to deal with are the fact that like the cloud providers are just eating the world, right? They're starting to buy physical cables and build physical cables. Facebook has one of the most ambitious cable projects anyone's ever attempted, which is this like giant round the world network that they're building out. And, it's one of these things where we could wake up in 10 years and be in a world where like all of the internet is basically centralized under 3 or 4 companies. And we don't think that's great, because these companies, what they're doing is they're trying to buy the physical infrastructure layer, right? The same way that like DirecTV and all these like, AT&T are starting to try and buy like HBO, you have like the Web 2 content companies like Facebook and Meta starting to try and buy physical infrastructure too. And their profit margins are just bigger. And that's why AWS is such a powerhouse it is, and GCP and everything too. And so, we really feel like we have to create a credible alternative to the Web 2 companies as well, because if you want indie games to be able to survive, they can't all be running on Microsoft Azure for their game engines.
It's a good point, and it just reminds me, like, as we kind of go through this decentralized future, it really does look like this sort of kind of cohort of all of these competing interests that are all incentivized maybe around the same outcome or the same maybe token. And so, you have, for instance, jump trading, and maybe we'll just say ABC Trading Company. I don't know if that's a real company, but we'll just say that's a company. And they're competitors in the open marketplace. They don't really want to share data. They don't want to like give other people advantages and stuff. But how do you basically incentivize them to come onto the network and share their resources and kind of be a part of this? Is there a token component to this?
Absolutely. Yeah. I mean, tokens are when you're talking about incentive alignment, there are few things that work better than a token, honestly. And so, this is kind of the way we view this system is like if you are coming to something like the DoubleZero network and you're saying, hey, I'm going to bring capacity with me, validators are going to pay as a percentage of their earnings to operate on the network. And so that means that suddenly we have a whole bunch of pool of contributor rewards. And so if you are coming in and you're bringing a network link that's quite useful, you'll be rewarded more for providing that network link. If you're bringing a network link that's less useful, we basically use Shapley values to determine the incremental value that each link produces in the network. And
compensate them as such.
Yeah, exactly. And so the other thing too is this is the first time that we've seen a network built where there's a revenue share model, right? So typically if you go and you're a fiber provider and let's say Jump Trading is buying cable from you, they're paying you, they might be paying you $300,000 a month for a really fast link, but they're paying you in US dollars for that link. And one of the nice things about DoubleZero is folks will actually be paid as a percentage of the economic activity going over it.
Wow, that sounds awesome. And and at the end of the day, I think I heard you mention testnet. Is this something that you guys are feeling like we're 6 to 12 months out, or is this still we just started and before we could kind of get this out in the wild, it's going to be several years?
No, we are aiming to go live this year.
Oh wow,
with Mainnet. So,
that's awesome.
Yeah.
Okay, well we'll definitely have you back on when you go live with Mainnet to get the full breakdown. But while you're here, I remember last time we spoke, you had a political science background as well.
Yes.
And am I right?
Yes.
Yeah. And obviously the crypto climate, because we want to take a look at just with you kind of what's going on in the world governmentally with crypto, and obviously there's a lot that's been changing. But how do you kind of think about DoubleZero growing in this new environment, right? Because if we think about those past 4 years, it was very antagonistic to crypto founders, and nobody was talking about crypto being on the governmental balance sheet. Nobody was thinking about crypto really much more than potentially speculative investments. Now people are like, hey, this could Elon's redoing the government, the treasury. Maybe they're going to add blockchains there. They're letting people really let their imagination run wild with how much crypto could get intertwined here. What's your take on all this?
So I would say the change in DC is like palpable. We feel it constantly in crypto. The difference between an administration that viewed crypto as something that they wanted to remove and one that views crypto as something they want to support or at least don't care particularly much about. The change in tone at the SEC dropping all of these lawsuits has been really, really interesting to watch and see. Now, at the same time, you've got a bunch of like noise doesn't mean anything, like the strategic digital asset reserve and stuff. It's just noise. Like we actually don't want the government. We don't want the government owning all these tokens. Like you really want the next like Bitcoin like downfall to be because like someone in Treasury decided this was a good time to sell $2 billion worth of Bitcoin. like the minute, this is the thing that people never understand is if you want the government to buy, at some point you've also got to want the government to sell, right? And then at that point, like, oh, then yeah, you didn't like when the VCs are dumping on you. Imagine how much you're going to like when the Treasury Department's dumping on you. And so this is the thing with the strategic reserve is it never really made much sense to me. Like, but we'll set that aside for a minute. The rest of the change in DC is really noticeable. We have companies reaching out to us, saying, hey, do you want to come to DC with us? Like we're going to talk to a bunch of senators and House members and their staffers and Senate Banking Committee and these sorts of things about crypto and crypto policy and how to make sure that stablecoins further U.S. dollar dominance and help us maintain the U.S. dollar as the global reserve currency, against rising pressure elsewhere. And that is suddenly a pro-America, pro-national security, blockchain-powered thing. right? And like,
Totally.
yeah, it's not the same thing at all about like this next gen of defense companies that are like, furthering America's national security interests in a very different way. But as we all know, economic security is a real form of security. And so, maintaining US dollar dominance is a really powerful thing globally. And crypto can play a really big part in that. The other piece I think that we finally got through within DC is like this idea that US founders are being pushed abroad for no reason, and none of them actually want to go abroad. We're seeing some US founders start to come back. One thing I have been trying to push for and lobby for is basically crypto foundation repatriation. So in the first Trump administration, they did this big thing where companies were allowed to bring back money that they were holding overseas, and they had some special carve-outs that didn't have to pay huge amounts of taxes on it.
Interesting.
No crypto foundation wants to be based in the Caymans. No crypto foundation wants to be in Panama. Maybe they want to be in Switzerland. They don't want to be in Dubai. They don't want to be in the UAE. They don't want to be in Abu Dhabi. There's nothing wrong with those places, but they're just simply much less politically stable and legally stable than the United States. The United States is the best country in the world to build a business in. And so if we can carve out a framework where crypto foundations are able to move back to the United States, they're able to get the same types of like carve outs and protections that they would get abroad, no one's opposed to paying taxes, right? The US has the most startups and the most profitable startups of anywhere in the world. Like, as long as we can get those same types of carve outs for crypto foundations, a bunch of folks would love to move back to the United States. And so my hope is that over the next 4 years, we are going to see a framework developed and passed through Congress that allows crypto companies to come back to the United States and be based here.
Well, man, that's a really hot take, and I'm glad I asked the question. I know it's kind of out of left field, but it's and I knew you're the guy to ask it to, because that's something I have not heard anybody kind of propose yet. It's a very original thought, and very cool to kind of hear you break that down. And yeah, I know you said you've got different folks reaching out to you to get to DC. I hope you're saying yes, because as a guy who's kind of in the same industry and so on, definitely would love to have you represent our industry to the folks that are decision makers in DC, because you're well spoken, and you also speak their language as well. So
yeah, we have
saying yes.
Well, thank you. I am doing a bit of it, but we also have we have a great collection of people down in DC nowadays, actually, as an industry. I think they often don't get enough of a shout out to like the folks at Coin Center who like, they are the ones standing up for your digital civil liberties. They are the ones who fought the Tornado Cash sanction and won. Like, Coin Center deserves your money and your donation. Blockchain Association's doing some great things. There's great Bitcoin groups as well, advocating down in DC. And then Stand With Crypto, right? The Coinbase thing. As much as Coinbase, is competitive with a bunch of crypto things in some areas, there's other areas like public policy where like Paul and the team in DC have been doing an incredible job lobbying for the industry. And so I think the biggest thing is just like, don't get too jaded with DC. Politics is always messy. Things always move slower than you want. But that's not a reason to tune out engagement with DC, because at the end of the day, like, it is how change happens.
Totally. Yeah. Somebody was on the podcast show recently and was like, people ask me why I spend so much time he's like a hedge fund manager. He's like, why do people spend so much time in DC? Every line of policy that's written moves the market $1 billion one way or another, right? It unlocks or restricts that value. So he's like, you just got to be close to the policy.
Yeah.
And
100%.
No, awesome. This was awesome. And again, like I said, when you launch Mainnet, we'd love to have you back on. Before we let you go, where can people stay in touch with the journey and maybe even get involved?
Yeah, so DoubleZero.xyz is our main website. It's got links to join as a validator if you want to run a Solana validator or RPC on testnet. We also have links to contribute bandwidth if you run a fiber network or you're interested in starting one up. Or also DoubleZero on Twitter. You can find me there at Austin_Federa.
Awesome. And for those who are listening, that'll all be in the show notes as well. And that's DoubleZero spelled out DOUBLEZERO.xyz, not just 00.
Yes.
Wanted that to be clear, because I don't know what's at 00.
No, I appreciate
it. But that's one that you need to buy. You need to buy that domain.
Oh man, talk about something we need an open market for, domain buying.
Awesome. Well, hey, we appreciate your time, and everybody home listening, we appreciate your time. Thanks for tuning in. Come back same time, same place next week. We'll have some more great guests for you. Take care.